Okay, let's continue. And basically today we do a little bit of revision on what we learned on Wednesday. So there's a software for you to help you to do the project planning. It's called Microsoft Projects. So one of the network is called PERT. So as you can see here, you have the event and activity. Event activity. And sometimes they have a sync point or blast point. So for PERT network, there are few types. So one is blast point, means one go into 3 or 2, and then sync means is go from a few projects or few event go into one project. So the arrow, it tell you the order that you should consider when you run the projects. Okay. And the rest we read. Okay. So this Wednesday, our previous class, we already go through how to change from Gantt chart into AON or AOA chart. The Gantt chart, this one. And then this is a milestone. Milestone chart means what you need to reach at a certain time. Okay, the rest you also read. So these are the proposed steps that we already covered in our previous class. So when you build a network, you need to consider the time that you needed, start and end. And then usually in the test or assessment or in your final exam question, also you will see something like this, something this table rather than a network. So you'll see a table, activity, title, then immediate precision means when you start B, you need to wait until A to start. Precedent means you need to wait, like B, you need to wait for A, C, you need to wait for A, D, you need to wait for B, and so on. Then activity time here is a mean. So our previous class also, we go through a way to calculate by statistic method, and then you do hypothesis, whether you can achieve it or not, how many percent you can achieve, right? So this is a mean time. And then if the table give you 3 numbers, means optimum time, pessimistic time, and most probably time. The A, B, and M number. Okay. So this is very typical that you've seen in the previous lecture, right? So from one station to another station. Okay. So we already covered what is critical path. Critical path is the longest time that you need, or in this case is the longest time in the network that you can commit to your customers, right? So critical path, there are 4 ways of doing it or finding it. One is through you calculate the longest path, right? The first method. Second, you go to your rubrics, ES, LS, EF, and LF. The second method is you look at the numbers in the middle column. Third method, you look at the third column. As long as they are same, ES equal to LS, EF equal to LF, then they are the critical path member. Number fourth, you calculate slack time. How to calculate slack time? You take LF minus LS. So if you get the slack time 0, means it's a critical path member, for example. Sorry, EF. Okay, so today just a revision for what we already covered. It's just as additional information. What is the difference between PRT and CPM? Okay, as you can see on the slide here. So PRT, they use 3 times estimates, where PRT, you will see 3 numbers, A, M, and B, and you need to find the mean by using A plus 4M plus B divided by 6 to find the mean. Then both CPM, they use dummy, and usually PRT they use for R&D, CPM they use for construction, and so on. So this difference between the two. Another method that rarely used in our module of project management is called graphic method or graphical evaluation and review technique, GERT or graphic method. As you can see on the screen here, the graphic method is a bit messy. If you have a very complex projects, you'll see arrow come in and here and there, and it can reverse the loop. So it's quite complex for project management. So GRT won't be asked in the assessment. Okay. Okay, there are 3 types of dependency, means the parameter you use to do analysis. Mandatory dependency means hard logic is a parameter that you cannot change. You cannot change. For example, mandatory dependent means you need to set up the wall before you put the roof when you build a house. Discretionary dependent, this one is soft logic. It based on the wisdom of the project manager. Like you can play around which one can go first. Right? External dependency, this one is beyond control of project manager. For example, in your project, you have an external contractor that in charge of that process. Slack time, we already analyze using the rubrics. So mathematically, slack time, you take the earliest time, the latest time minus the earliest time. Okay, means latest finish minus earliest finish. Okay, so this is a very simplified diagram. Please use the 6-box presentation in your test. This is just a elaboration on what we learned so far. Okay, so this one is a very old textbook, but it's just additional information for you. So if you build the 6 rubrics, 6-box, you can see everything rather than you do one by one calculation like this. Right? It's the same thing, but this one is more organized. and you can straight away see what you need to do or what activity is critical, you cannot move or cannot touch. This one you read lah. Okay. Okay, so this one already covered. Some presentation they use like this rather than box. I still prefer using the 6 box rather than the number here. It's still the same. The arrangement still same. C is the activity. This is the time. Then this is the earliest start, earliest finish, latest finish, and latest start. A bit different, huh? Orient or sorry. Latest. Correct. Same. Okay. Right. So is it similar? It just changed the. This is activity on the arrow. This is AOA. This is AON. This is AOA. The one that you see on the screen here is AOA, activity on the arrow. The one that you did for the 6 boxes one, that is AON, activity on the node. Okay. So it depends on the question whether it asks you to use this one or this one. So don't confuse between the two methods, AOA and AON. Okay. Okay, the rest you read from the slide. Actually, it's keep repeating what is we have covered so far. We also covered previous class. We also covered what is forward pass, what is back pass. So again, what is important for forward pass? What number you use if you need to make decision? You be conservative. You take maximum number. If you work from the back pass, you choose the minimum number. Means the way you fill in LS and ES. Okay. Slack time can be negative. Slack time negative when your forward pass extend beyond customer end date, which is you have a bad planning when you, let's say the finish date that in your early calculation is maybe 59 days, but you go to negative slack when you or finish date. But usually in the question for your test or final exam, we won't give you negative numbers. Okay. If you go to work later, you use software, usually it will prompt you with the red color, something wrong with your time, right? Or there's a delay in here and there. Okay. This one also you read lah. Okay. Okay, maximum float. Maximum float is another measurement that you can calculate the maximum float. Maximum float means the time that you can play around in the whole projects. You take the latest finish, LF minus ES minus the duration of the time. Yeah, this one is schedule development. You go through a few process. So you develop schedule, then you go to resource, then you go to management review, then go to execution. Okay, you start a schedule, you look at resources, you look at management review, then you execute. So if you cannot pass the management review, you need to go back for feedback, right? For feedback, then you go back to your schedule, then you look back resource control. Resource here, you look at cost, time, and resources. Okay, it still remain the project management success definition. You need to meet cost, time, quality, and customer requirement. This four. This one you read lah. This one is just for if you need to replanning, then how you adjust the things. Okay, for example, if you look at this diagram, this network, the time need from station 1 to station 2 is 3 days, let's say, or 3 minutes and so on. 1 to 3, you need 2 minutes or 2 days. So here, from process 1 and 3 and 1 and 2, you can have a replanning here. Means you can either start 1 to 2 first, then you can wait. When there's a delay in here, you can still go for 1 to 3. Means 1 to 3 process, it will give you some time to play around. So sometimes you can reconstructing. You can just change the station or sequence. Let's say you see the network on the left and on the right. What you do is that you flip the sequence of 2 to 3 means activity 2 to 3. You see, you flip. When you flip, the time can shorten from 15 to 14, for example. So in Wednesday class, a previous class, what we do is we do with one set. Then what if the question continue to ask you, is there any way to reconstruct or replanning the network? Means you play around, you try to switch from, look at the diagram. So you say the question will use keyword like, if some activity A and activity B required the same manpower, can you replan the network? So you go into that particular station. For example, in this case, you look at 1 to 2, 1 to 3, then you see whether you can flip them, and then you find, is there any changes to the final time or not? Means you look at the critical member, right? You look at the critical path member, then you try to swap the critical path member. You cannot change the critical path member, but you can swap the sequence. See whether you can swap or not. If cannot swap, then that is the replanning results still the same. Means you use back the original plannings. Okay. The one that you see on the slide here is just tell you that to show you that when you flip 1 to 2, 1 to 3 sequence, you can save 1 week from there. The rest is the same. The process still the same. Okay. This is called replanning. Okay, so there are 2 techniques for replanning. One is resource leveling, means you look at the resource and then try to divide the resources into the need station. Another one is allocation, resource limited planning. So this one is attempt to find the shortest possible critical path. Okay. The first one is leveling. Leveling means you eliminate the peak process or the peak manpower that you need. Okay. One method is called parallelization. Parallelization can be regarded as accepting a risk by assuming a certain event can begin parallel with a second event that normally be in sequence with it. So you see series number 1, 1, 2, 6. The total time you need is 20 weeks. But if you split 2 to 3 become parallel, you split them. Parallel means process 1 start already, then you start 2. Process 1 finish already, you start 3, become parallel. The total time you need for that project can reduce from 20 to 16, for example. Okay, so from here, 4 to 0, 16, 0. So critical path, you always find the maximum time you need for the project. So here becomes 16, but here become 20. Means that you like open up the channel for the water flow. Okay. Another network is called segmented chart. Segmented chart means you pull the process into more detailed plannings. So for example, activity A to G is a car assembly process, but you can pull out activity D into another segmented network. Like for example, you pull out the doors assembly segment. So you pull out one for D. This is called segmented lah. Okay. So estimation we already done in the previous example. You have 3: optimistic, pessimistic, and most likely. Okay, so this one also you read lah. What actually does it mean? Hey, yeah. Okay. Okay.
Job or internship recruitment. So if you guys are in the final year or final STEM or you guys want to be going for your internship, I think this is the right choice for you to you can just come and have a network with them, or if you have resume prepared and then you can bring your resume as well. So we have companies actually hiring for job and internship. So it is on the next Wednesday. If you guys want to register, there's a banner all over. You just can scan to register. So I just came here to inform about that. Thank you.
Right. Okay, so you should be familiar with this formula. A plus 4m plus B by 6. So when you need to use this one is when the question you see optimistic, pessimistic, and most likely time. Then you use this one. And when you use this one, it means that it asks you to predict already lah. The next procedure is to predict lah. Okay. Then this one is standard variation. Standard variation is a square root of what you find. Okay, so these are the formula. Variance, in previous example, we use variance. Then we find standard variation. Okay. Critical path, estimating total time. So critical path, straight away you look at the network, look at the last rubrics or last column of your 6 box there. Look at the last 2 number. Usually they are the time needed for that project. Huh? Okay. So in textbook that you see when you have 3 times there, the one on the left will be A, the one in the middle will be M, the one at the right will be B. Huh? A, M, and B. Then use the formula to find the mean. You need to convert these three number into min, then only you can build the box, the 6 box. Okay. Okay, the rest you read lah. Then later I give you one exercise. Then you see whether you able to do it lah. Okay, so again, the total path, this one also will show you the standard variation for the projects already. Okay, so statistics. Later we learn about Six Sigma. So statistics, if you have 1 sigma, it means you are concerning 68% of the confidence level. If you have 2 sigma, 0 to 2, 0 to 2, so it means you have 4 quadrant confidence level, 55%. So if you go for 6 sigma, means 3 quadrant, or 3 sector, you have 6 sigma, then you are covering 99.7 of the data. You do prediction. This is a normal graph. So it depends on where is your numbers lah. Okay, so the example that we see previously is let's say the production is 25 days and you promise customer 30 days, means you can, the confidence level is on the right, positive one, right, plus the 50%, right? If you promise the date less than your network, it will go to the left hand side. Then you calculate the area on the left. Okay. Okay. So this is example that you have been going through from using A, M, and B value. So when you see these 3 value, most of the time you need to find the mean number, and then from the mean number you have you can find the standard variation and the variant. Okay. So what does the variance? Variant 1 means plus minus 1 day. Plus minus 1 day. Okay, the rest just explanation on the statistic graph. Okay. So it means if you use this data, your total is from your network is 15 days. Then if you promise your customers we can deliver 16, means your confidence level is higher. So it will be on 50% plus 68%. Here is 68. Here is 68%. Right? And so on. This one also the same. We already learned all these steps in Wednesday class. So basically, this is just an add-on information. This one also for your information only. Okay. In the industry, we are more concerned on the time, cost, and risk that you involve. These are the 3 from your network. You can do analysis on the time, cost, and the risk. This one already covered in the previous slides, where there's a difference between PRT and CPM. So for your information only. Okay, now it's about cost. Okay, Okay, let me go back here. Okay, so let's say you have a network like this. So you have activity, time required, put at the side, and activity identification, for example, this one. Then you're given a table. So activity A is 4 weeks. Let's say weeks are 4 weeks is here. B, 6 weeks. C, 2 weeks. D, 2 weeks. E, 7 weeks. F is 6 weeks. Then you have one more column here. Crash 2 weeks, 5 weeks, 1 week, 1 week, 1 week here. So then there's a cost. If you go for normal process, means 1 week will cost you 10,000, right? 1 week will cost you 10,000. So this one crash, if it crash, 1 week will cost you 14,000, for example, right? And then this is a crashing cost per week, 2,000. Let's read. Okay. Now, how to find the 2,000? If you crash, if your process crash A process crash, the cost will be 14,000. Normal operation 10,000. The differences is 4,000. But in the process, you crash 2 weeks. So you take 4,000 divided by 2, you get 2,000. How you get 1,250? You need 6 weeks, crash 5 weeks. Normal is 3,000, crash is 4,250. You take 4,250 minus 3,000. You get 1,250, right? But what is the crash time? The crash time will be 1 week. Okay. And so on. So for example, this one, 2,000, 20,000, 29,000. So how you get 3,000? 29 minus 20, 9,000. So you get the differences is 3 weeks. Divide by 3, you get 3,000. Okay. 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 So this time I'm not going to ask you about crash time lah, but it's inside your syllabus. This one you read lah. CPM is AOA. PERT is AON. It's actually it will come out, but it's just a different presentation. Okay, this one, okay, this one you read lah. Okay, so okay, how to come up with this graph by using this table. So once you draw y-axis as your cost, x-axis as your time, then you go one by one. First, you go for normal operation. If your process run normally, what is the total cost you need? If you take 10,000, 30,000 plus sum total, you get 120,000. Correct? You add 10, 30, 40, 48, 100, 120. Okay, so if everything run normal, this is the normal operation cost. then crash. When the system crash from activity 1 up to F, what happens if there's a crash in the process? You add all the process costs, you will get on the top, all process. You add all the activities, you'll get minimum, maximum. Minimum is a normal process. Maximum is when everything you have a very bad luck. Every week you have crash one. So maximum cost will be 165K. So you draw the minimum, maximum. Okay. So assume there's no critical path developed. Activity A, F, E, B would crash in that order. So your crash, let's say you have crash A, F, E, B. So when you crash A, means you follow this sequence, right? You crash A. So the time here, 23 is that you calculate the critical path lah. You calculate the critical path. Let's say you add all the numbers, like critical numbers is A, B, E, F. So you add 4, 6, 7, 6, you get 23. So all the critical member give you 23 weeks. Then you start from 23 weeks. Okay. So 23 weeks, you crash A. A is 2 weeks. So you reverse 23 minus 2, you arrive at 21. So you draw one line there. You draw backward. If normal operation, but you crash A, the cost will go up a little bit. Okay, will go up a little bit. Okay. Then what is the height of this one? How to find this point? This point you know lah, starting point. Crash A, then it go up there. So 2 weeks, right? It crashed 2 weeks. What is the cost of 2 weeks? 2,000. So 4,000. So here 124 is here. This point is 124. From 1200 up to 124 in 2 weeks. Then you continue with the F and so on. Okay. We go for the lower. You see the sequence, the cost here. We go to F because F is the second lowest cost. A is the 2,000 only one. Then F is a 3,000. Then the next one will be E. E is 6,000. Then the next one will be F. F will be not F. Next one will be B. We arrange we work backward based on the cost. Let's say A crash, what is the minimum? B is the second, and so on. Normally, we will look at the crushing cost per week to build this graph by sequence, by the cost numbers value here. Cannot say wrong also lah. Cannot say wrong also, because you want to estimate. You want to see what is the cost that involved when you start the programs, right? So you back in this way, you can jump the thing, but the purpose of doing this is to visualize what happened if F happened or B happened. It means this one we build from the low to high, low to high. So when after you develop this graph, when you read this graph, you know that when you start normal operation from here, then what happened if the most serious case happened in F? you know already maximum crash will give you 165K, and then it continue with the activity number B. You want to find the minimum total cost. Of course, you say you want to jump also can one, because when you add all the costs, you still arrive at minimum cost total. Our objective is to find this one. So you can jump lah, but textbook procedure, they follow the value of the caching cost here. You can jump, no problem. Important is you pick the critical member and then you put inside your calculation. The objective is to find this one. You add the four critical member, you add here. Let's say four event also, the 4 member were crashing, keep crashing. Then the minimum pocket money you need for your project is this one. You add up here. Then you tell the investor maximum, the bad luck is 165, and minimum is here. So you need to calculate what is the value you need. 2K and so on. So 115.7K is your minimum cost if all the critical parts crash. Make sense, huh? But anyway, I won't ask you in the test. Okay. It's just that for your project management, later you know what need to consider when you work with a vendor, you work with the company. Okay. So from here, 1200, you can go up to 157 if your critical member all fail or crash. Okay. Your cost you can increase 37,000 if 4 critical member crash. And responding time would be then reduced from 22 weeks to 15 weeks. So it will reduce from here. Completion times, it will reduce from here to here. If you can avoid crash A, B, E, F, your completion time can almost cut half already. If you can jaga all the critical member, you actually can reduce half. The rest you read lah. This is a qualitative presentation, cost versus time. So you have early start of activity and later start of activity. So there is a cost involved when you start early and when you start late. So there's a region for there to play around. So cost also, you have direct cost and indirect cost. So when you combine direct and indirect, you get a curve like that. Okay. So you want to find the minimum point of your total cost for your whole projects. At what stage will give you the minimum cost. Okay. So this is, you already know this one. You convert into 6 rubrics already. This one you read now. Precedence network, this one also same, but it's just this one is like a milestone one. It's like a Gantt chart lah. It's more like a Gantt chart. So if you have a solid line, then it's related. Like activity task 1 and task 2, they are related. Weeks 1, months number 1, they are related. Then they can wait activity 2, they can wait until the 4th month. Then they can only start with activity number 5 and so on. Okay. Okay, so there are a few relationship. We always use the finish to start relationship, but some company, they will give you start to start, means the diagram that they do is start to start, means when they start activity 1, they can start 2 also already. Finish to finish means this one end to end. Okay. Start to start, the advantages is that you know when you can start an object, the project. Finish to finish, you know that you need to watch out for the time frame where both activity must finish at the same time. Okay, this one. Start to finish, this one is a loop, which means if you get a start to finish the network, meaning you need to play around the time frame between activity 1 and activity 2. Okay. Okay, but this one also I rarely ask this kind of question. Percentage of complete means activity 1 you finish 50%, then you fit into activity number 2 20%. Okay, so 50%, 20% means last 20% of activity 2 cannot be started until 50% of activity 1 has been completed. For example, this one is more in construction, more in construction. This one more complex, where they monitor the whole projects. You have all these numbers. Okay. Lag is okay. Lag and slack, the differences is slack measure within activities, lag measure between activities. So time between the early start and finish of one activity and the early start or finish another activity is sequentially called lag. But anyway, most of the time I will ask you slack. What is the slack? Means you use the 6 rubrics here, 6 box here. You take this one minus this one. This one also you read for your information. This one you read, read. Okay, so this is a small quiz to sum up this chapter 5. The shortest time necessary to complete all activity in a network is called what? Critical path. Which of the following cannot be identified after performing forward and backward pass? C, confirm can. Slack time you can find. Dummy activity. How you calculate overtime? Dummy you can split because why? When you draw network, you still remember sometime your sketch, you arrive at this one. Then you change this one cannot. You change this one to dummy activity. This one dummy. You change this one to this one. When you do network. Okay, so network cannot allow 2 arrows go into one. Cannot allow. You can only use dummy to split them. Okay. So overtime you cannot. Schedule. Which of the following is not commonly used technique for schedule compression? not commonly techniques. What you look at just now, resource, time, and scope lah. So resource reduction. Okay, but anyway, number 3, not commonly used technique for schedule compression. Scope, fast track, overtime. Okay, this one, why is A? Because it asks you about schedule compression. When you do network, you don't consider resources. You only talk about time, right? So network-based schedule have 4 paths, 7, 8, 9, 10 weeks. If the 10-week path is compressed to 8 weeks, then means you have 4 paths lah. You have 7, 8, 9, 10. So critical time is 10. Now you squeeze your time become 8. You do replanning, then you change to 8. So in here, there's not enough information provided. So because you don't know, you don't know the precedent, you don't know the relationship between, you cannot draw the diagram yet. It only tell you the path, but you don't know the relationship between the activities. Right? So this one also, you didn't build the network, how you know it's critical path. So critical path is not 9 weeks, it should be 10 weeks. If you have 3 times, maximum time is your critical path. Right? Only 7 weeks, we don't know. We need to draw the 6 box, then only we can know. Major disadvantages using bar chart is what? Very obvious lah. A lah. Cannot see the different the dependency. First step in developing a schedule is first step. Listing lah, list activities. Reducing peak values in manpower assignment in order to obtain relative smooth manpower curve is called we have 2 leveling and allocation. So this one is called leveling. Leveling. Activity with no time duration is called dummy. Okay, number 9. Optimistic, pessimistic, most likely activity time associated with PRT. PRT, which commonly constrain relationship in proceeding network. This one is a finish to start lah. Okay, you always finish to start . Network technique follow for branching and looping. This one branching looping just now. I still remember. The one that I say very complex one can go back on. Graphic G. Graphic. The one they have a lot of loop on. Okay. If an activity on the critical path takes longer than anticipated, then what? Activity not on the critical path have additional slack. Mean is what? It means it's shifted. Let's say this is critical path. Then the activity on the critical path takes longer than anticipated. Let's say this one at 1. So this one at 1. So this one non-critical. You will have at 1 also. Means you have not at 1 but there's a play time for these activities to play around, because this is not critical. Which of the following is not one of the 3 types of dependency? You have mandatory, discretionary, and external, right? So remember, mandatory means you need to build the wall before you put the roof. Discretionary means based on the wisdom of the project manager, they can stop the activities. External is the one that out control of the project manager. Okay, so internal is no lah. No, right? You have an activity where early start is 6 weeks, early finish 10 weeks, latest start is 14 weeks, latest finish. So it's a slack. You know lah, this one minus this one lah. Yeah. Okay, with this we conclude chapter 5. Five attendance.